Next, we asked Josh to explain what labeling requirements might be needed for electron beam usage and if it's related to the Radura symbol that's required for gamma ray sterilization.
The Radura is actually required for most foods that are directly treated with electron beam, as they are with gamma. I think that recently there's some rethinking of, in certain cases, if certain low dose treatments are delivered to the food, it's more of a processing aid as opposed to an additive. There are some applications being thought of where potentially it doesn't require labeling, and these are ones where you're delivering a low dose to the surface of a food product in order to either extend the shelf life or just reduce the surface contamination. As opposed to traditional gamma or big electron beam technologies where you really are full sterilizing the entire food product. So I think potentially it may be treated differently in the near future, but as of right now, the Radura is required on all foods treated with E-beam as well.
Going back a bit again to the PET bottles and maybe materials that might be used for, say, aseptic processes, is E-beam an alternative? Has it been tested to hydrogen peroxide or anything like that?
Yeah, exactly. The traditional chemical sterilization technologies are probably the traditional one is peracetic acid. Vaporized hydrogen peroxide has been used more recently. E-beam is a chemical-free alternative to both of those technologies. And this applies both to PET bottles, where it's widely used, but also dairy cup, whether it's a form-fill seal or a preformed cup application, and also increasingly in the pouch. The pouch is one of the fastest-growing packaging formats. There's increased interest in doing beverage pouch, and the ability to aseptically fill a beverage pouch is complex. You can imagine that it's difficult to sterilize the inside of a beverage pouch in line with chemicals because it's very difficult to rinse it. So electron beam actually will pass through thin films of material. So there are applications where we can actually take a closed pouch pre-filled and send it through an electron beam, and you're actually able to sterilize the interior of the pouch with no chemicals, and then fill it in line at very high speed. So,
aside from the advantages there might be in replacing some of these chemical means, can you confirm then that the production rates would stay the same? There wouldn't be any loss in throughput?
Oh, absolutely not. In fact, that's one of the benefits is that low voltage electron beam delivers sterilizing doses, and actually, given the history of electron beam use in the pharmaceutical space, it's very well understood the sterilizing power of electron beams, and we can deliver a sterilizing dose to surfaces in milliseconds. So it's a very high-speed process, and the whole idea is to actually enable high-speed inline sterilization in filling processes. So,
in terms of FDA acceptance, are those types of applications ready to go, or is there still some approvals that need to be worked through?
The nice thing about, again, the history of E-beam use in the pharmaceutical space is that the FDA understands it quite well, and as do the process authorities out there that help in the validation of these lines. Given that you're delivering the energy that is controlled really digitally through a power supply, there are very few key process parameters to monitor. Much fewer than there are in the chemical space. Setting up a line, you're essentially determining that the configuration of delivering sterilizing doses to every piece of the packaging material. And once you turn the line on, that doesn't change. The laws of physics don't change. The electrons always come out of the beams as they did yesterday, and then the sterilization kinetics don't change. So you're able to monitor it digitally, verify it digitally, and that simplicity is valued by the end users as also by the FDA.
How aware are your customers or potential customers for this technology? Is some work need to be done on the education side?
I think, always there's need for education. It certainly is growing in interest. We're at the point where we're getting a lot more unsolicited calls. But certainly I think we're up against the idea that the traditional concept of electron beams is that it is a large, bulky, complex technology, along the lines of a gamma radiation. So there certainly is, education needs to get done on both the safety of the equipment, the commercial status of the equipment, and then a wide range of possibilities. I think that we've talked about a few here, PET bottles, cups, pouches, but I think that there are a lot of process challenges out in the industry that with creative thinking and the flexible sterilization technology, we might have a solution. So and we're always out talking and brainstorming with end users and industry experts.
It seems like it's kind of lumped together with gamma technology. Is that a public relations challenge for you and your company?
I would say, yeah, there certainly is the fear of radiation technologies. There are several key differences between E-beam and gamma. Probably the most important is that there's no radioactive source. So gamma relies on a radioactive isotope decaying in a controlled fashion. E-beam, there's no radioactive source. You're just accelerating electrons that come out of the wall. So that's a challenge. We are always out also assuring people that this is a safe technology. And there are electron beams installed in certainly every state in the U.S. and certainly every country in Europe and in Japan and major industrial nations out there. So there is track record of using this technology very, very safely and very effectively.
In sort of near term and looking into 2009, what can we look for from E-beam in this coming year?
In 2009, I think you'll start to see early trials of bottle sterilization concepts, certainly cap sterilization concepts, and also in the cup sterilization area for dairy type applications. We're looking forward to some early deployments here in 2009.